Hi everyone, I'm SimoColo-Projects and I'm currently studying to become an electronic and telecommunication engineer. And I want to show you one of my favorite projects so far. This is my Meshtastic node. It's a small LoRa-based device that lets you send messages without any Wi-Fi, cellular data or internet connection. I will explain how does it work and how I built it. Before diving in my setup, let's talk about what exactly Meshtastic is. It's an open source project that uses LoRa, a long-range, low-power radio technology, to create a mesh network. That means each node can forward messages to others, expanding coverage without any central server, Wi-Fi or cell tower. So if you send a message from your phone, your node transmits it via LoRa. The signal can travel several kilometers and hop through other nodes until it reaches the destination, even if there's no internet at all. My node is built around the Heltec V3 board. It includes everything I needed: a ESP32 microcontroller, a LoRa transceiver, and a small LED display. I didn't have to add any additional components. For power, I use a 5V with 1200 mAh battery that is rechargeable through USB-C. I found this case design on MakerWorld. It was already very well done, but my battery was slightly bigger than the box where it was supposed to go in, so I modified the STL file to make more space for the battery. I printed the front with PLA and the back with PETG to handle the battery heat. The result is a sturdy compact case that perfectly fits the Heltec board and antenna. I installed the last Meshtastic firmware, which was very easy to do because you have just to insert a USB-C cable from this device to your MacBook and click on flash. After flashing, the board automatically pairs with the Meshtastic mobile app via Bluetooth. I configure it to see the medium range fast profile for Italy, which balances coverage and data rate. In the past week, I brought it with me for every single thing I did, like for example go to university or stay at home, and I discovered at least 250 nodes. I just wanted to see how many nodes I could reach and how the network behaves in a normal environment, and it was impressive. I already received the signal from more than 250 nodes, some directly and others through several hops. The system currently supports up to 7 hops. I also have another node mounted on my rooftop, which helps expand coverage, although one hop is already used just to reach it. In urban areas, I noticed that the range drops significantly because of obstacles or buildings, and they make interference. But this is part of why I think this is really interesting, seeing how real-world conditions affect the LoRa performance. And that's exactly why I'm planning a new test. This weekend I will take the node to the mountains for a high-altitude field test. I want to see how far I can reach when there is a clear line of sight, and maybe discover completely new nodes from up there. I will also record GPS and telemetry data to analyze how the signal behaves with elevation. This goal is to understand how terrain and height impact hoop, performance and signal stability. This project taught me a lot. I have learned how antenna design and orientation can drastically change performance. Even small details matter. It also gave me practical experience about low power communication systems and radio propagation. But above all, it showed me how useful these devices are when traditional communication drops, for example during emergencies. Here is what exactly happens when you send a message. Your phone sends data to the node via Bluetooth. The node then transmits it over LoRa to nearby nodes. Each one repeats the process hop by hop until the packet reaches its destination. It's a simple yet powerful concept that makes the whole system decentralized and resilient. My next goal is to keep improving the network. I want to add more nodes around my area and probably integrate some sensors, like for example humidity, temperature or GPS, to turn it in a small IoT mesh. If you found this project interesting, feel free to check the links below. You will find the link for the firmware and you probably will find my contacts. Thanks for watching, I'm SimoColo-Projects, and this is just the beginning of my journey in electronics and telecommunications.